hands first. What was that about? Welcome, guys, to the last class.
I know. All right, so today we're gonna go through this quiz 11.2 and 11.3. Eat lots of pizza and lots of desserts and things. There's some really good things in it. And then we're gonna review a little bit of the exam 4 materials, chapters 10 and 11. And then we're gonna review a little bit. We're probably gonna get through chapters a little bit of 2 and 3 and 5 a little bit. And then one thing I want to talk to you guys about during the break. Okay, so today you have Connect Math 11.2 due tonight, and also Lab 10. You can turn that in late for full credit. Sunday you have your last Connect Math due 11.3, and then obviously your final is next Thursday, and we talked about the percentages already. There'll be a review session in here, 7, a little bit early, 7 to 8:30. Good? Or you can come earlier, 5:30 to 7 if you want. The finals can be grouped by exam. So, like one of the finals will have the exam 1 material kind of mixed up within that, but all grouped together. And then the exam 2 material, then the exam 3 material, and then the exam 4 material. Except there might be like one problem that like is 1 page away because of like, you know, how it all works and grouping it together. The other exam will have exam 4 material, then exam 3 material, then exam 2 material, then exam 1 material. Good? Okay. Yeah?
So we don't have class on Tuesday?
We do not have class on Tuesday. I'll be in here on Tuesday until 8:30 working on problems from chapters 4, 5, and 6 so you guys can kind of remember them. Okay. Good. If you want to take the file early, you can take it early on Tuesday at either 9:30 or 11:30. Okay. In here. Is anybody interested in doing that? Okay. All right. So you need to be here, either do the 9:30 starting time or the 11:30 starting time. You can't come in between that. It's got to be one or the other. It's all start, finish, start, finish. So either one. Here's the study guide for the final. Those problems, which we've done a few times before, we talked about this before, is also on Canvas. Here are my office hours for next week. The ones in blue are the study sessions, so don't come talk to me about personal stuff on those days, those times. But the other times, we can have like private conversations about this, that, or the other if you need to discuss anything. Or just email me if those times at work and we can try to find a time. All right, so correlation coefficient. Rho. Remember, it's that weird P. You kind of take the P, you kind of just go up and you loop around, right? Rho. That's the population correlation coefficient. You're going to compare that to R, your sample correlation coefficient. It goes from -1 to +1. The smallest it can be is -1. The largest it can be is +1. Those are perfect lines. If it's -1, it's a perfect line with a negative slope. If it's +1, it's a perfect line with a positive slope. All the points lie in a perfect line. If it's 0, that means it's kind of like, think of a 0, it's like a circle, right? All the lines are just, all the points are just making a big giant ball, kind of. They're randomly assorted. So that's no correlation. So this is your H naught. No correlation. Not a line. These ones are your, if you reject H naught, then you'd say it is a line. It's out here, or out there. So that would be like your H1. The other thing is to calculate your R. So before we did it the hard way, like that, but really now we're just using the stat test, Limreg t-test. You put your X's in list 1, your Y's in list 2. Limreg t-test will give you your R. It'll also give you your A and your B. So it kind of gives you everything, and your p-value. And again, like I said, H naught is rho equals 0. So this means not a line, no correlation. H1 would be is a line. So there is a correlation. So that would be H1. This is H naught. Good? The regression line, you can just use limit t-test to find your A and B, but this part's important. Jimmy, go to read the parts in red and blue.
For valid predictions, the value of the correlation coefficient must be significant.
Right, so that means that you have to have rejected H naught. It is a line. If it is a line to reject H naught, then you can use that line up there. Read the other one.
When rho is not significantly different from 0, the best predictor of y is the mean of the data value of y.
Right, so this is reject H naught. You use that. If you do not reject H naught, then you use y equals y bar. Why does, right? So if you is a line, then y equals a plus bx. If you do not reject H naught, it's not a line, so use y equals y bar. That's your best guess for y. And that kind of makes sense, right? Because remember we talked about like test grades and shoe size. Are those correlated?
No.
So what's my best guess at the score of somebody who has a size 12 shoe?
Mean.
The mean, the class average. Right? Y bar. Great. Goodness of fit. So again, that's where we have some categories, and we observe we observe a sample, and we see people going into different categories, and we have sort of frequencies that we observe, and we have frequencies that we expected them to be, and we compare what we observed to what we expected to see if they're the same or not. So the chi-squared is our computation there, O minus E squared divided by E, and then you add all those up. Degrees of freedom is the number of categories minus 1. We'll go and do a quick example. So here, what are my categories, guys? This is what we did last class. Reusable, plastic, and paper. And we have observed and expected. So what did I observe? I observed plastic. How many plastic?
1.3.
How many paper? 8, and then it leaves 152 reusable. Now, we expected, please remember, the observed, we just give you those. You just write them down. That's what you get from the sample. The expected, you have to calculate. You have to take the total number of people surveyed and multiply by the probability for that category. So what percentage do we expect for the reusable? 60%.
60%.
60%, so that would be 0.60 times 300. What about for the plastic? 32%? So 0.32 times 300. Everybody kind of on board with this part?
Yes.
180, we expect 96 here. We expect 8%, 0.08 times 300, 24 here.
Yeah.
So then our chi-squared, remember you have to calculate that by hand, well not by hand, but you have to write it out, so I see the formula, would be my observed, 152, minus my expected, 180, squared divided by my expected, 180. Plus the next one, 120, minus 96, squared divided by 96, plus 28, minus 24, squared divided by 24. That's showing your work for this one. This is kind of the only one of that group you have to do it for, but you have to show me at least once. There's only 3 of them. I'm only going to give you 3 of them. It's not a lot. Just go with it, right? It's not that much. It's really not that much. Now, if you want to actually calculate, you could put your observes into list 1, right? You put your expecteds into list 2. And then into list 3, you would put your observed minus, your observed is your L1 minus your expected L2 squared divided by your expected, which is L2. And you're going to put that into list 3. That's the sum part. That's the this part, but they have to sum them. So the last step is your chi-squared. Is actually the sum of all of these. So the sum of your list 3's, which is sum of your x's in list 3. How do you do that? How do you do that?
1 bar stat.
Yep, 1 bar stats. Or you could do 2 bar stats if you wanted to. 1 bar stats. Good? Of list 3. Questions? Everybody feel good about this part? Great. Now, 11.2 is our contingency tables. So we can either do a test of independence or test of homogeneity of proportions. Can you take some pizza home with you?
No, I don't want to eat pizza home.
Look at that, sounds good. All right, so first let's define what a contingency table is. It's where we have that, did I do this right? Oh yeah. Okay,
Yep.
good. It's that table where you have stuff categories along the side and categories across the top. Right, so categories here, categories there, and you have this matrix on the inside. So that's why I call it chi-squared matrix. Chi-squared matrix. Because there's this matrix here. Because you have categories here and you have categories there. And this is kind of simpler because you just do you put this matrix into A. I'll show you guys how very quickly. So again, to get to the matrix, you do second, and then matrix is the 4th one down. Or on some calculators, it would be a button kind of right here that says matrix right on it, and you just hit that one if that's what you have. And then you go to edit over here. The first one's A, hit enter. And say I wanted a 3 by 3 matrix. This is 2 by 3. I wanted 3 rows and 3 columns. See, all of a sudden as soon as I do that, it gives me 3 rows and 3 columns. And you just go down there and you start inputting them. So you hit like 24, enter, and then it just puts it in, and hit enter, it goes to the next one. Once you get that, to figure out your chi-squared, you'd hit stat, test, and go up to chi-squared test, this one right there. And you want your observeds in matrix A. That means you're telling it, I have put the observed values from the sample into matrix A. It will compute the expected for you and store that into matrix B. You don't have to put anything in matrix B. It will overwrite matrix B and put the new expected values into that one. So you just hit calculate there, and it will give you your oops. Oh, because I have some zeros in my matrix. I can't have that. Yeah, that's not good. I think I can have 1 0 at least. Okay. So, dash out.
Like this.
Yeah, I can have 1 0. I can't have. Okay, so then it gets my chi-squared 59.776. See my p-value? Is my p-value 3.23?
No.
No, you can't have p-value again as your probability of getting that sample. You can't have probability more than 100%. So if you have something over 1, you better be looking for an E negative something there, right? So this is E negative 12, which means you have 12 zeros, and then your number. And you could just I would just put 3.23 E negative 12, because once you get, if you have more than like 7 zeros, just write E negative whatever, because that's too many zeros for you to write. That's a little insane. And then you can also double check the degrees of freedom, make sure you got that right. Degrees of freedom is 4. So remember, it's your number of rows minus 1 multiplied by number of columns minus 1. That's your degrees of freedom for this one.
Mm-hmm.
So that's this stuff here. The other thing you have to do is you have to check your expected, why am I talking to you without getting to that? So degrees of freedom, number of rows minus 1 times number of columns minus 1. You do not have to write out 29 minus 32.7 squared divided by 32.7. But you do have to give me the expected frequencies for the first and the last. So for the line, the chi-squared line, you have to compute all the expected frequencies, right? For this one, you only have to, because there's so many of them, you only have to compute the first one and the last one. So in the matrix we did before, would compute, this is the first one, row 1, column 1, and this one, what's this one, what row is this one?
Row 2,
The second row,
column 3.
yeah, and which column? Third column. So this is, remember RC cola, row column, it's the second row, third column, so 2, 3. So we'd find the row total multiplied by the column total divided by the grand total. All on board?
Yes.
Okay. Good. So that's everything that we need to know there. And then the last thing that's kind of important is a reminder. H naught for the 11.2, it's one of these 4 things. Oh, sorry. 11.2, your H naught. It's no, in this case, no relationship, which means independent, right? If it doesn't have a relationship, you're independent of each other.
Yes.
So in other words, is rolling a dice related to flipping a coin?
No.
No, they're independent of each other. Make sense? So, no relationship, independent, no difference, no preference. The matching H1s for these would be, is a relationship, is dependent, so that's the opposite of independent, is a difference, is a preference. So depending on what your claim was, you would use one of those words for your H naught and the corresponding words for your H1. However, I'll let you guys just get away with the cheap, easy way of just doing O sub I equals E sub I, and O sub I doesn't equal E sub I. All right.
The homework does a good job with like implanting that in your brain.
Oh, good.
Really cementing it in there.
Cool.
Because you have to go through every single one and be like equals, doesn't equal.
Right. So yeah, so do the homeworks because they're helpful.
Sometimes the website doesn't work that well.
Yeah, I know.
It's got issues. Like I
It does
just
have
was
issues.
opening it on my computer and it would
Oh,
load the screens, but it like
okay. So what you need? Sometimes it's because your whatchamacallits aren't. Oh, your Flash isn't always.
Yeah.
Your plugin isn't always accepted.
Google is.
but why?
I don't know. Switch computers and
I
try.
did. I switched
Yeah.
computers and then it let me get to like problem 6 and then it did it again, wouldn't load anything.
I don't know. Email me.
Got stuck on that screen.
Yeah. Sorry. Okay.
Repeated.
So you guys are done with this one, right?
Yes.
Let's go ahead and go through it. These parentheses, ignore them. That's where most people would normally put in the expected values. Typically, they put the expected values in there. But I'm not going to give it to you like that. I'm just going to give you the numbers. Okay. All right. So first step, H naught and H1. H naught's what?
I equals E sub I.
Yep. And what is that? Which one does that correlate to up here? What are we saying? Which one? What's our claim? And they are
Independent.
So it's independent, the H naught or the H1?
H naught.
H naught. So this is independent. So that one is my claim. So I'm doing the whole thing to reject or not reject my claim. Remember H naught 11.1, 11.2. It's on the file. It's going to be about rejecting or not rejecting your claim, because your claim is going to be H naught. So the H1 is what?
O sub I is not equal E sub I.
Right? Which means that they would be what? Dependent. Perfect. All right. Next step. Alpha find my critical value. So my alpha is what?
0.05.
right? And my degrees of freedom
2.
is, yeah, so we do
2
R
minus
minus 1 times C minus 1. So that is
2 minus
2
1.
minus 1 times 3 minus 1. So that's 2.
Mm-hmm.
So your critical value is
5.991.
5.991. And then you're going to draw this nice little picture where you go straight up and then kind of drift off that way. 5.991. What was that? Okay. I know. That's okay. Step 3, you need to find your test stats. So, but first you need to find the two expected values. So the first one is going to be E1, comma 1.
Uh-huh.
So what number are you going to grab from there?
1,001
Yeah, so this is E11. I need my
column. I mean
row total and my column total divided by my grand total. So 1158 times 51.
Divided by 14, 1945.
And you guys got 0.34?
6.
36? Okay, that's good. And then what's this last one down here? E what?
E2, comma 3.
2, comma
3.
3. Second row, third column. RC colon, row column. E2, comma 3. And that's going to be
787.
787 times 1409.
Uh-huh. Divided by 1940.
And you guys got
570.12.
0.1. Okay, great. And then you're going to stick, this is your matrix. Oops. And this is matrix A for you. Right?
Uh-huh.
And you're going to do stat test
Chi-squared.
chi-squared test of matrix A. And you got chi-squared is equal to 112.1. Point what?
374.
374. Great, 37. So then you throw that in, it's way over here. Somewhere, even further away than that. But that's just in the gray, in this shaded area. That's good. So was it unusual? Very unusual. It's way out there. Unusual is when it's over here. This is usual. This is unusual. So it's unusual, or we're going to reject H naught?
Yeah.
Yes, it's super unusual. So then step 5, we have enough evidence to reject our claim, because our claim is H naught, that, what was it? Just take the words out of here. Being the victim of a crime is independent of knowing the criminal.
What did you say is independent?
I would say being victim is independent of independent of what?
Knowing the criminal.
You can say, I would say, I mean, maybe, you have to say victim, independent, and criminal. You have to have like those keywords in there.
Okay.
Independent of knowing.
I didn't say independent, but I did say there's no relationship.
Okay, okay. Okay, you can say, yeah, independent is the same thing as no relationship, right?
Right.
So remember, if you're independent, you're not in relationships. You're mean.
You're mean.
Alright. Okay, here we go. Chapter 11.3, ANOVA. So this one, so the first two we hit this, Brenda brought in sparkling cider. Nice job. Okay.
You gotta pop it open though.
Yeah, we did top it up. All right. Let's go through this kind of quickly, and then or do you guys want to take a break now and pop it open and then come back?
Dude.
All right.
Bottles and stuff.
What was that?
Is that even a question?
Right. All right, quick break.